Welcome back, everybody. Welcome back to the channel. So today we're going to be talking about how to process and manage imports. So this is going to be the portion of code where we have like an import here, where as you can see, I say import stdio, and this is going to import everything from the standard library. Now the way this is going to work is basically, it works as you guys expect, right? So we're going to have basically code inside of like modules, right? So string is inside of the standard library. So whenever you import a module, you're going to import everything inside of there that's underneath that umbrella of that module. So if I go into here at the high level or at the very beginning, what we do is we basically, so I have this option that's called magic mode. And if I go to, what is it, main.cpp, main.cpp, and that is located inside of the grammar file. And if I do a search for dash magic, this enables a magic mode. This is a Easter egg that I added for my compiler. You guys don't really need this. I do think it is kind of cool though to kind of have this. Basically what it does is it just imports everything. So of course that could cause collisions with importing stuff, which is entirely possible. But basically what you want to do is you want to for loop through every single parser. If you remember, each parser represents a single file. We want to set our current parser that we're processing to whatever it is, and then we want to update our error management instance. We've already seen that function. All we do is just pass in the current parser that we're parsing, and it will appropriately update the error management system. After that, we need to get our total errors count. So we need to get a log of the total errors and determine if we have found any new errors during the import process, because there's entirely possible that we're trying to import something that doesn't exist. Now, here's where the cool stuff kind of comes in handy, right? So we have this handle imports. Oh, it's actually in the to file. So we have this handle imports function. If I go back here, and if you guys remember, this is the preprocess function. And we have this code at the beginning of every single file when we're pre-processing, where we're effectively creating the module. So this guarantees that by the time we get down to handling imports, we've basically created and ran through every single file that we have that the user has provided to us, and we've created all the necessary modules and packages that are related to each file. So if we go back into handle imports, what you want to do is first check to see if we have magic mode enabled. Now again, you might not have this, so what you do is, here's basically how it works. So we're going to have what's called a import map. So if I go to the actual code here, the import map is going to be a reference to the file data. And if you guys remember, file data is a reference to a file. So each file has a name and a GUID and whether or not it wants to be obfuscated. The reason why I want to do that is because when we generate code, we're going to, like in our exceptions, explain where the code is located. So if I go to like this ODF file, which is short for object dump file, you can see here that we have all this various different information about this function. And in this instance, it's an operator overload. And you can see here we list out the file. So it doesn't make sense to have code obfuscation unless you obfuscate the file. Because if you don't obfuscate it, then you know what the name of the class is by just denoting whatever the file name is. So we use that information for imports in order to basically keep track of where the file or what file it's actually representing. So each file is going to have a list of module data. You guys know what module data is? The module data is going to be a reference to each module that we're going to be referencing in our actual code. So each file is going to have a list of modules. Now, by default, we always want to import the standard module or the standard library. So that's going to be the module std, and that's going to be an umbrella to basically allow the user to do the most basic things. So if they have a string, or if they have, I don't know, integers or whatever, you want to create an int class, then they can do all of that stuff. So if we go back to our compiler and we go to handle imports, we can see here that in magic mode, so if we have it, we create what's called a new key. Now this is a key pair, right? So if we go back here, this is a list of a key pair. Yeah. So the key, right, and a key pair, the key is going to be the file data. That's going to be a reference to what file. The value is going to be the list of modules. So we want to create a new key where we get the file based off of the current parser that we're inside of. So we access the current parser, we get the tokenizer that's connected to that parser, and then we access the name of the file. So this is just going to be a string, which is going to be the name of the file. We pass that into our obfuscation system. It's going to locate that file and return us back a reference. Once we get that, then we want to just call init on the value. And init is a function that is inside of our list class. Again, if you guys ended up copying the list class that's inside of my util file, or no, it's actually in my backend grammar. Yeah. So if you ended up copying the list file that's inside of the grammar folder, then you would have to call init. Otherwise, whatever list you have, you just want to make sure you initialize it. After that, you want to just do a simple add all. So you want to basically access all the modules. So I'm going to access the modules list, which is just going to be a list of references of all the modules in our entire programming language. And the add all function is just going to add all of those references to the current file, and that's it. And then after that, we want to check to see if we have any new errors that are found. As you can see here, here's what the code does. It literally just checks to see if the new total amount of unfiltered errors is greater or minus the errors that we logged when we first started. Is greater than 0. If so, that means that we have located more errors than we originally came into this function with. And then we add that to the failed parsers. Now, here's a normal case where probably most of you guys would actually have this code being implemented, is you're going to want to have a list of imports, which is going to be a list of references of the module data. And then what you want to do is you want to add the standard library by default. Now, if some of you guys remember, I know some of you may be thinking, well, what if we have code obfuscation enabled? Code obfuscation only happens at the end of the compilation process, so we don't have to worry about this being some other weird name. So we pass the name std, and we get that module, and we add that as a default. That's very important. You want to make sure you do that. After that, we want to for loop through all of the files, or every single, not every single file. We want to for loop through the entire current parser that we're processing. So this is going to be the current file, and we're going to go through every single AST in that file. So we're going to get a branch, which is going to be a sub AST inside of the parser. Once you get the branch, then you want to, basically do the preliminary stuff where we add the module as the first item. Now, this is very important. This is not pointless. The reason why we want to do this is because it makes sense, right? Like, we know that at the very beginning of this, we're going to have a module declaration. So we need to parse that module by calling parse module declaration, and we want to add that module because technically speaking, right, if we have, let's say this module was something else, or let's make it a more legible name. Let's say it was named main. Now I have a standard in my programming language where I'm sort of building a list of recommended things to do in the programming language, and this is one of them. Basically, what this standard states is that the main portion of your code should be in the module called main. So that's where your main function is, that's where your primary classes are, and everything else. And then just like Java, if you have subfolders and everything, you should name them appropriately depending on the data structure of each folder. So if we go with the main example, you want to import main. So basically what this will turn into is import std, right? So we're going to import that by default, and then we're also going to import main. The user should not have to manually put that in because that doesn't make any sense. So just make sure you do that. Let me revert this back because otherwise I'll get errors. So if I go back here, so we add that by getting the module from the code obfuscation system. We also set the current module to the module that we just received. This is completely unnecessary. You don't really need to do this, but I do it anyway. Otherwise, I set the current module equal to undefined, and I add that to the imports list. So it's still very important to add this value to the imports list of undefined module because technically speaking, if they didn't have this defined at the top, we still want to process everything correctly. So yeah. After that, we want to do a switch statement on each branch, and all we care about are imports. Now, we're kind of at a point where we've pretty much processed everything. So I'm going to put a space here so I can go back to it very quickly. But if I go to compile, we've already pre-processed everything. We've pre-processed classes, generic classes, subclasses inside of there, as well as fields and other stuff, right? So we don't really need to, like I said, care about whether or not we have a malformed AST, because at this point, it's safe to assume that we're okay when we're at this stage. So I just basically expect AST imports and ignore the rest. Ignore for now, that's an incorrect statement. But yeah, I ignore all of the other ASTs. And before we jump in there, you also want to check for any compiler errors to just make sure if you went over the error threshold that we return out of this function. And finally, before we actually get into pre-processing imports, this is how we add the imports to the actual file and attach it. We basically create a new key. We get the file by accessing the current tokenizer and getting the name of the file and accessing that from the file code obfuscation system. We initialize our value and then we add all of our values. This is the exact same code that we saw previously when we were doing the magic mode. So once all that code is set up, you want to create your pre-process import declarations. Now you want to pass in not only the branch, but you also want to pass in a reference to this imports list because, of course, we're processing imports outside of this function, so you want to just pass that in just in case if they had a module declaration correctly created from the beginning. So as you can see here, here are the parameter arguments for this. And after that, here's how we do other stuff. So I also have a way in my programming language where we basically can say stdio.everything. And what that does is that allows the user to not have to type in import stdio dot I don't know, task, stdio dot file, or just any other sub modules that we may have. So what we do is we want to first figure out what is the name of the actual thing we're trying to import. So what we do is we go through we do a for loop on the branch's token count. So the branch that we're passing into this function is going to be the actual AST for imports. So we're going to expect that all these tokens are going to be inside of that AST. So we go back and we for loop through it. We check to see if the current token that we're processing is not equal to a star. If so, we want to add it to this string stream. The string stream is going to represent the actual full name of that module. Otherwise, we must have found a star and we want to immediately break. The reason why is because we know that our parser is going to immediately expect a semicolon after a star. So we're not going to have like star dot, some other crap after it because our parser doesn't allow that. So after that, we want to have a string module of ss.string, which is the string version of the string stream. That's going to be the name of the module. Now, I'm actually going to go through really quick to show you guys how this processing actually works because I think it is important to see. But let me just explain it first and then we'll run through the code quickly immediately afterwards. So, and I'll do both examples where you have like a regular module or a regular import and then a import with a star. So we have what's called our base module. What our base module is going to do is it's going to be a substring of 0 to module.size -1. The reason why you want to do that is because the way that this is going to work is as we're processing this, right, we're only checking for if the branch value or the actual token value is not equal to a star. That means that if we have the case where we're processing stdio.star, we're going to have all of the code from std all the way up to the dot. So the reason why we want to get a substring of stdio is because we want to capture the std.io part. So if we end up having a star, we can import this value of stdio as well as any subsequent modules that are inside of that module. So that's why we get a substring of -1. So if I go back, so once we get the base module, now this is only going to work if we have a star. If we don't have a star, we're just going to ignore this field here. But we're going to have a module data of package, and that's just going to be a local variable. So let's look at the case where it's not a star. All right, so we're going to ignore this code for now. If we scroll down to the normal case where we just have an std.io, we're going to just access, or we're going to set this package variable of module data to whatever the value is. So we're going to just pass in the string version of this module, which is going to be the full name of this because it's not broken up because of this star here. And we just try to see if we can add that module. Now, if you remember, add if checks to see if the thing that we're trying to add is already present. If so, it returns a false. Otherwise, it returns true if it successfully added it. So if add if fails, we want to say w general and we want to say module whatever is already imported. We don't have to error out because they can import the same module more than once. It's not that big of a deal. Not going to hurt anything, but we don't want to add it more than once. Otherwise, if the package that we are assigned from the code obfuscator is equal to null, then that must mean that the module doesn't exist because we've already processed every single file that the user has provided to us. So we're going to say module whatever could not be found, and we're going to create a generic error. Okay, so let's look at the case where we have a star. If we have a star, meaning that we have the stdio wildcard, then what we're going to do is we're going to first get the package of the based module, and we're going to check to see if that's not equal to null. And what that's going to do is that's going to be the std.io part, like I talked about before, and we're going to just try to add that module if it already exists. Now, we don't want to give them a warning here because they could theoretically say import stdio at the top and then stdio dot everything. And I don't know, it's just personal preference, but I didn't think it was that big of a deal, so I just didn't put an error there or a warning. So yeah, we want to try to add that, and then we want to for loop through every single module in our code obfuscation system, and we want to check to see if the module starts with the name, or we want to pass in the name of that module, and we want to see if it starts with the mod, right? So the mod part in our example is going to be std.io dot, and the base mod is going to be std.io. So that's going to be the value without the dot behind it. So that's how we were able to add it here. And when we do our search, the idea is that if you're going to have a module that's going to be a submodule, it's going to have this information. That way we don't like add this one more than once because it doesn't have the dot in the name. So we're just going to check to see if anything starts with that. And I created this function starts with, it's just a helper function. I have several helper functions here. I think we went over this already. But as you can see, it's a fairly simple function. I don't think I have to explain it. You guys can just pause the video and copy it down. It just compares two strings to see if if the prefix is at the beginning of the string that we pass in. So if I go back, so if we found it, we say found is equal to true, and we add that module to, or we try to add that module to the imports list. Now there's a case where the user could have potentially said import std.io dot, something, and we just don't want to add it more than once. So there's that. And the reason why you don't want to add it more than once is because when we're resolving fields and data on the back end, I know it may seem harmless, but that's going to exponentially increase the processing time of resolving information if you have duplicate modules that you're importing because you're traversing those entire modules more than once. So that's why you don't want to add it. And now if we did not find it, we will say modules under prefix mod, which is going to be in our example stdio dot, and then we put the star immediately afterwards because we know that the module name is not going to have the star inside of it. So we want to say modules under prefix, stdio dot star could not be found. Why is my computer frozen? Yeah, so that's how we actually error out, and that's it. So that's how I process and handle modules. Now let's actually look at a real example so we can see what the compiler is doing real time, and then we can just finish up on the video. All right, so we have this example where we have this main file, which is, I'm actually starting to rewrite the compiler all over again. And this is actually the compiler in the language itself. So we have this example where we have like a main .sharp file, and we have a couple of imports here. So let's go through some of the imports. So this one's going to be pretty basic. So I'm just going to hop over this one, and we can see the results. So if I hop over that and then I go down, we can see here that the module is std.io. Now we're going to process this one first, and then we're going to process this one afterwards. So this one, all I did was just run through here. Now we're going to look at the base module, and the base module is going to be std.i. It doesn't have a dot in this one, or it doesn't have the star, so we're not going to use this one. So it doesn't apply here. So as you can see, I jumped over the star check, and we basically are just going to access this package. So now package, if I do a check for that, package is now equal to std.io, and this is the reference of that module that was created in the code obfuscation system. I'm going to add that module successfully, and we're going to destroy the instances of each string. So I'm just going to hit continue again, Now we're back at the top, and now we're going to be processing std IO with a star. So if I hit if I put a breakpoint here, you can see that we get to a point to where we have a star, meaning that the current token that we're processing is not equal, or is equal to, a star. So if I hit break, I go here, the module name, the actual module is going to be stdio dot, and then the base module is going to be stdio. So as you can see here, everything's working correctly as expected. If I move this over, we're now going to go into the star if block, and we're going to say found is equal to false, and we're going to try to locate the base module. The base module is stdio because we want to import this one, including anything that is after stdio. So we do that, and then we're going to check to see if we have anything. Now I have no idea if we have anything inside of there. Okay, so I guess we do. So now we're just going to add that module as well. And let's see, so if I hit continue again, all right, so now we're out of the loop here. Now we're going to check to see if we did not found it. Well, we came in here, so found is equal to true, so we do not get this error, and we're all good to go. So, and of course we have one more, but we don't have to go over that. But that's pretty much everything today, guys. If you have any questions, definitely put them in the comment section below. Also, if you have any additional questions or anything else, you can always email me at devcode.channel@gmail.com. That is in the description below. So definitely email me with any questions or suggestions that you may have. Also, if you guys would love to help support the channel, of course, you can go to my GitHub repository at andrewdevcd/sharp. And when you do, definitely watch, star, and fork this repository. That's going to give this repository a lot more visibility and let other developers know this language exists. Also, if you're curious about what I've been up to on a daily basis, you can head over to the remastered branch and you can check out the commits. I write some pretty decent commits, so you kind of get a gist of what I've been up to without really having to look too much into the code. Also, if you guys are curious about maybe some of the things that I'm looking to add in the future to the language, or things that I've done in the past, you can head over to the docs folder, and there's two main files. You can check out the change list. That's going to be all the old stuff that I've done to the language in terms of updates and releases. The roadmap file contains all that information, as well as things that I'm looking to add in the future. So hope you guys enjoyed the video. As usual, if you're new to the channel, definitely consider subscribing, and until next time, I'll see you guys later.